All right, here's an example of the type of problem you might run into with Learning Objective 2, which deals specifically with problems where you're looking at constant acceleration. This could be an object moving on an inclined plane. It could be a car accelerating with a constant acceleration, so it would be moving horizontally, and it also includes free fall. Our example has to do with free fall. So I saw this YouTube video where the challenge was to catch a basketball thrown from the top of a 110-meter high building. That's actually really high. And so the point was, like, could you catch it? So the person that did catch the basketball, and they did a fine job of it, did show that they got some bruises, particularly when the basketball hit their wrist and also hit their watch, which caused a bruise on their arm. But anyway, that's the basis of this particular problem. We're going to imagine that we're throwing a basketball from the top of this building. We are going to make it just go straight up, just thrown so that it won't hit the building on the way down. So it is going to be one-dimensional, free fall. So I'm going to put my y equals 0. I'm going to put it at the base of the building, which means that our y naught is going to be 110 meters because that's the height of the building. That means that I could, I think that I didn't mention this, that when we throw it upward, we're throwing it upward with the speed of 15 meters per second. So these pieces of information are going to allow me to write the specific expressions for this problem for the position and for the velocity. So the general equations are y is equal to y naught plus v naught t minus 1/2 gt squared, and v is equal to v naught minus gt. So in this case, g is 9.8 meters per second squared. The negative sign has already been put into the expression, so we don't have to make that a minus 9.8. So using those basic kinematic equations for free fall, the equation for position in this particular problem would be y is equal to 110 plus 15t minus 4.9 t squared, and v is equal to 15 minus 9.8 t. So these are the equations that govern the motion in this particular problem. The first thing that we're asked is, how high above the building does the basketball rise before it starts to fall back down? So when it reaches its maximum height, which is really what we're being told or asked for, that's when the velocity goes to 0, because at this point right here, wherever this is, it has been going in the positive direction. It's going to stop and then turn around and go in the negative direction. So this will tell us the time that we know when it reaches the maximum height, which we will then use in the y equation. So we let v equal 0, and that's equal to 15 minus 9.8 t. So t is 15 over 9.8. So the time is 1.53 seconds. Then y is going to, now we want to evaluate the position at that time. So it's 110 plus 15 times 1.53 minus 4.9 times 1.53 squared. And that gives us a position of 121.49 meters. Now remember, this is measured from the base, because when I originally started this problem, I said the base of the building is going to be my y equals 0. I actually want to know this difference, the height above the top of the building, because that's what the question asks. And so I know that y is equal to 110 plus h is this 121.49. So my h is actually going to be 11.49 meters. So it went 11.5 meters up from the top of the building before it started to come back down. Part B asks, what is the total time the basketball is in the air? That's from like when you throw it till it hits the ground at the base of the building. So to find the time in the air, I know that when it hits the base of the building, y will be equal to 0. And I want to find that time. So you can see that we have to solve a quadratic equation. I'm fine if you have that programmed on your calculator. I would not allow you to use your computer to look up a quadratic solver. So it might be a good idea for you to be familiar how to solve a quadratic by hand in the occasional times when you're going to need to do it. When I do it, I really hate when the coefficient of the t squared is negative, so I'm going to just change this all around. And so then t, I use this as, ax squared plus bx plus c equals 0. That's the form I'm putting it in. And then my t is negative b, which is 15, plus or minus the square root of b squared, which is 15 squared, minus 4 ac. And that's all over 2a. And so that's how I solve for time. Remember, t must be positive. Because we don't go back in time. So the t that I would use from this expression here would be the one that was positive, which would be 6.5 seconds. The other solution that I get from this expression would be negative, and that wouldn't make any sense to me. So the time that it's in the air is 6.5 seconds. So if you think about it, it's kind of a long time. Now finally, I want to know the speed of the ball when it hits the ground. So I already know it's in the air for 6.5 seconds. So I basically want to just find the velocity at 6.5 seconds. And if I do that, I find minus 48.8 meters per second. But the speed is actually just the magnitude of the velocity. And so that's 48.8 meters per second. It's just going, that's how fast it's going, is the speed. The negative sign is the direction, but because I was asked for the speed, I don't really need to include that. I just am being asked, how fast was it going? So here's an example of a problem that we might run into on our assessments when we're looking at constant acceleration.